This lesson is multiplying monomials, chapter 4, section 3. When we're multiplying monomials, we're talking about something, because they're monomials, we're talking about problems that don't have any addition and subtraction in them. Our first one is x to the third times x to the fourth. If we write x to the third in expanded form, that looks like x times x times x. That's x to the third. We want to multiply that times x to the fourth, which looks like x times x times x times x. How many x's do we have? We have 7 x's there, but we're multiplying them, not adding them, so that is x to the 7th. The next problem we're going to look at is 2x cubed times 5x squared. I'm going to reorder this a little bit. Since it's all multiplication, we can do it in any order, and I'm going to put my coefficients together. So 2 times 5, and then times x cubed times x squared. Well, 2 times 5 is 10. X to the third is x times x times x. X squared is x times x. So we have 10x to the 5th. Do you notice a pattern with what's happening with our exponents? We had x cubed times x squared, and we got x to the 5th. On the one before, we had x to the third and x to the fourth gave us x to the 7th. You notice what's happening? We're adding our exponents. When we have 3 to the 4th and 3 to the 2nd, if we add our exponents, that would give us 3 to the 6th. Let's write it out in expanded form just to check. 3 times 3 times 3 is 3 to the 4th, times 3 squared is 3 times 3, so that gives us 3 to the 6th. You notice our base doesn't change. The only thing that's changing is our exponents. 4 plus 2 gave us 6. Our rule for this, which you learned last year in pre-algebra, is that when we're multiplying monomials, we add our exponents. So x to the a times x to the d times x to the d is x to the a plus d plus d. See that little play on words? So when we're multiplying monomials, we want to add our exponents. Now we're going to look at a couple problems where you have a few more variables to deal with, not necessarily just one. This is just one giant multiplication problem. We have parentheses separating it, but there is no addition and no subtraction. We're just going to multiply. So I'm going to multiply my coefficients. 2 times -4 is -8. X to the third times x to the fourth is going to be x to the 3 plus 4. Y to the first times y to the first is going to be y to the 1 plus 1. So -8 x to the 7th y squared. When you have fractions like we do here, you want to go ahead and simplify where you can before you multiply. We can simplify 2 and 10. That would be 1 and 5. If we look diagonally, we can also cancel our 5s. 5 goes into both of those once. Now we don't have anything that simplifies with the 8. Is that the only way we could simplify? No, we could have simplified the 2 with the 8 and made them 1 and 4 instead of doing the 2 with the 10. You can simplify anything on top with anything on bottom, and sometimes there's more than one way to do that. Now, you can just envision Mr. Borg doing his top times top and bottom times bottom dance. And we're going to do 1 times 1 on top is 1. X cubed times x squared is x to the 3 plus 2 over 8 times 1 is 8. We can go ahead and add our exponents. X to the 5th over 8. Could we also write that 1/8 x to the 5th? Sure. Either one of those answers, remember, those are the same. That's multiplying monomials. Now what's going to happen is we're going to do powers of monomials. So we're going to have a monomial inside taken to some power that's outside the parentheses. X cubed to the second power, if we write that in expanded form, means x cubed times x cubed. Because to square something means we multiply it times itself. Now we've got a monomial times a monomial. What do we do with our exponents? We add them, so we get x to the 6th. What did we do? How can we get from 3 and 2 to 6? Think about that. The next one is 4x squared to the 4th. I'm going to write that in expanded form also. 4x squared times 4x squared times 4x squared times 4x squared. So we need to multiply all of our coefficients. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 216. That's also 4 to the 4th. 216. X to the 2 plus 2 plus 2 plus 2 is x to the 8th. You'll notice we did 4 to the 4th as well as x squared to the 4th. When you have a power outside and there's more than one thing in here being multiplied, you have to apply your power to everything inside. That doesn't work when there's an addition sign, but right now we see that there's only a monomial in here. There's no addition and no subtraction. What did we do with our exponents there? That also worked for the first one. We multiplied them. You look at this little corny thing down here. X to the pro is taken to the power of duct. So we get x to the pro times duct, because product means what? Means multiply. If you liked it better, you could write x to the M-U-L-T to the I-P-L-Y is x to the M-U-L-T times I-P-L-Y. We're going to multiply. These are just pictures for you to get in your head. For this one, what is our coefficient here? Like you see that negative sign. Your coefficient is -1. So we can imagine this being -1 x to the 4th to the 5th power. So we need to do -1 to the 5th power and x to the 4th to the 5th power. Well, -1 to the 5th power is -1 times -1 times -1 times -1 times -1. We have an odd number of negatives, so that's going to be -1. So -1 x. We multiply our exponents, so x to the 20th. We can drop that 1 and leave it as negative x to the 20th. For the next one, we need to cube all those pieces inside. So 3 cubed is 3 times 3 times 3, which is 27. X squared to the 3rd power, we're gonna multiply those, x to the 6th. Y cubed to the 3rd power, we're going to multiply those exponents, that'll be y to the 9th. The last one on here, I just put as a little, well, I did a couple more, I guess. A little bonus for you. X to the a to the x to the x minus 1. What do we need to do with our exponents? We need to multiply them. So that's going to be a to the x times x minus 1. We'd go ahead and distribute that, a to the x squared minus x. It looks kind of strange, but we're just following that pattern. Here we have 3 to the 5th to the 4th. We're still just going to multiply our exponents. That's going to be 3 to the 20th. You see our base doesn't change, whether it's a variable or a whole number like 3 or a fraction. The base doesn't change. Only the exponents change. Alright, these are the ones I want you to try. You don't need your book this time. Go ahead and try these, and we will check them together in class. the next time I see you.